got a helicopter. You have to decide where you're going to draw your helicopter. I'm going to draw my helicopter. How do helicopters look like this? Does that look like a helicopter? Maybe. There's our helicopter. It's looking down at a car, and it is 1,000 meters above the ground. So here's my helicopter straight down 1,000 meters above the ground. Now an angle of depression is from a horizontal line looking down. So I'm going to just draw a horizontal line out from my helicopter. And at first, it sees the car at an angle of depression of 27 degrees. So I need to go down 27 degrees and hit a line, and then here's my car. Beautiful. Five seconds later, the cars move forward, and now I have an angle of depression, and I'll draw it in a different color, of 25 degrees. Wow, that's a nice straight line. Should maybe use a ruler. So at first the car is this far, and then it goes a little bit further. Maybe I don't like those lines there. Cars drive on a road, they don't drive in the air. Here we go. Start with green. Here's where the car is to begin with. There's my right angle. And then in the blue it goes a little bit further. Can you see the two right angle triangles? They're hidden again. Yes? There's a green one, which is a smaller one, and the 27 degrees isn't inside the triangle, but I can figure out what this angle is. How would I figure out that angle? Subtract it from 90. Can you see that it'll be 63 degrees? And one thing that always happens with an angle of depression is the angle of depression for the helicopter always equals the angle of elevation from the car's perspective. So if it's 27 up here, it'll be 27 down there. Same thing with the 25 here. In blue, that would leave 65 degrees left. And down here, from the car's perspective, the angle of elevation would be 25 degrees. So again, I'm going to draw our two right triangles. I'm not going to draw this skinny one. That's not a right angle triangle this time. I'm going to draw the first time where the angle of depression was 27 degrees. There's this triangle. This is 1,000. And the blue one as a second triangle. Helicopter is still 1,000 meters above. Now the angle of depression was 25 degrees. So that would make this 65 degrees up here. And again, a 90 degree there. What do we want to find? How far did the car travel in the 5 seconds? So the key thing I want to find is this x from here to here. How far it traveled in 5 seconds. And if we find out how far it travels in 5 seconds, we can use the same ideas we did in our conversions unit. We can actually figure out how fast this car is traveling by 2 measurements from a helicopter. And then they send you an envelope from the Winnipeg Police Department in the mail, and they say, would you like to give a donation for $500 or spend a week in prison? And then you give them the $500 for your speeding ticket. So we can find out if this guy was speeding. I don't think they have helicopter photo radar in Manitoba, but they do in Alberta. Not speaking from experience. I saw a sign. I didn't get a ticket. Whew. All right, so we'll see if this car is speeding or not, based on those angles. We want to find this x. Can you see in this green triangle, I could call this y. That would be this part right here. In the blue triangle, again, those two together, these two combined, I could call that z, which is equal to x plus y, and that z would appear here on my blue triangle. Do we have enough information to find y on our green triangle? Yes. Do we have enough information to find z on our blue triangle? Yes. So if we can find y and we can find z, then we can find x. Now you can choose, since we have all the angles, you can choose the 27 or the 63. Using SOHCAHTOA, you can't use the 90-degree angle for using SOHCAHTOA. It's always one of those acute angles. So when you're solving for this, first of all, you need to choose an angle. They will both work. Sometimes one is a little bit faster than the other, but not so much that it matters which one you pick. Which angle would you like to pick? 27? Okay. So if we're choosing the 27 angle, this is my opposite side. The one I want to find is my adjacent side. SOHCAHTOA. Which one has opposite and adjacent? Tan. So we'd go tan of 27 equals the opposite side over the adjacent side. This is the one that's a little bit longer because the y is on the bottom. Right? So you'd have to multiply both sides by y and then divide both sides by tan 27. What will happen is when you multiply both sides by y, the y will come to the top to the left side. And when you divide both sides by tan 27, if you do both of those steps at once, you'll get y equal to 1,000 over tan 27. (1,000) divided by tan of 27, 1962.6. Whoops. And I'm going to store that value, alpha y, so I have it for later. Same thing can happen with our other triangle. Pick an angle, 65 or 25. 65. If I want to find z and I'm using 65, z is the opposite side, and I know the adjacent side. So I'll use tan again. Tan of 65 equals opposite over adjacent. Multiply both sides by 1,000. (1,000) tan 65, and we get 2144.5. So now to find x, we just need to subtract them. And we have it stored in there. 181 meters in 5 seconds. Was he speeding?
Yes,
Depends on the speed limit. Find out how fast he's going. Tell me tomorrow.